Bismillah ar-Rahman ar-Rahim. Hello everybody. Today we will deal with a new type of undefined integral. It's about integral which involves cosine, sine, tangent, or both. As an example, we will try to solve to find this undefined integral at the last. So here there is a universal change of variable. This change of variable, we have some special cases when we can use other different change of variable, but the universal, it works each time. Obviously, we take tangent x over 2 equal to t, new variable. And here we have to describe cosine with relative to t, sine with respect to t, tangent with respect to t, and dx with respect to dt. For dx, from this formula, we have x equal to arc tangent x. Then we have t. Sorry, we have x over 2, so we have x equal to arctangent t, and then dx is equal to 2 over 1 plus t squared dt. So the first formula that we will need later is dx is equal to 2 over 1 plus t squared dt. Cosine x is equal to cosine x over 2 square minus sine square x over 2, and sine x is equal to 2 cosine x over 2 sine x over 2. So from this formula we have tangent x over 2. This is equal to sine x over 2 over cosine x over 2, and this is equal to t. So if we take here square, we get here square and here square and here square. This implies that t squared plus 1 is equal to sine square x over 2 over cosine square x over 2 plus 1. But this one, we will take it into a special formula. This is cosine x over 2 square over cosine square x over 2. And we have the same denominator and sine square and cosine square in the numerator, so this gives us 1 over cosine square x over 2. So this gives us 1 over cosine square x over 2. So we have cosine square x over 2. This is equal 1 over 1 plus t square. So we have this. With this, we take the inverse. But from basic trigonometry, one has 1 plus cosine x over 2. This is equal to cosine x over 2 square, which gives us, using this formula, so this will gives us 1 plus cosine x over 2 equal to 1 over 1 plus t square. We are here, which implies that cosine x is equal to, so we have 2 minus 1, we have 2 minus 1 minus t square, so 1 minus t square over 1 plus t square. 1 minus t square over 1 plus t square. And here we can write that if we are dealing with this kind of problems, we can take this change of variable and we have dx equal to 2 over 1 plus t squared dt, and cosine x is equal to 1 minus t square over 1 plus t square. So how about sine? How about sine? Sine x is equal to 2 sine x over 2 cosine x over 2. From this formula, we have cosine x over 2 square is equal to 1 over 1 plus t square, which gives us that cosine x over 2 is equal to 1 over the square root of 1 plus t square. And from this formula, we have that sine x over 2 square is equal 1 minus cosine x over 2 square, which is equal to 1 minus 1 over 1 plus t square, and this is equal to t square over. So sine x over 2 is equal to t, the square root of 1 plus t square. And from these two equation, this one and this one, this is equal to 2t over 1 plus t square. And here we have sine x, and here we have sine x equal to 2t over 1 plus t square. How about tangent x? For tangent x, equal to sine x over cosine x, which is equal to 2 sine x over 2 cosine x over 2 over cosine x over 2 square minus sine x over 2 square, which is equal to 2 we have cosine x over 2 sine cosine x over 2 square times sine x over 2. Here we have we have 1 minus tangent x over 2 square, and this will be cancelled with this, and we take this here. It gives us 2 tangent x over 2 over 1 minus tangent square x over 2. Then we can write that tangent x is equal to 2t over 1 minus t square, since tangent x over 2 is equal to t. So we have the equivalent formula that we can use in our calculation. As an example, we will try to solve this one. This is not easy. Honestly, this exercise was sent to me by one of my students. So I will try to solve it. So we have dx over 2 sine square x plus 3 cosine square x is equal to integral dx over 2 sine square x plus 3 cosine square x plus sine square x minus sine square x, which is equal to the integral dx over 2 sine square plus sine square, it gives us 3 plus 3 as factor. So here we have 3 minus sine square x, and this is equal to integral dx over the square root of 3 minus sine x times the square root of 3 plus sine x. And here we use the fractional decomposition. We get this is equal to 1 over 2 the square root of 3, the integral dx over the square root of 3 minus sine x plus 1 over plus 1 over the square root of, it gives us 1 over 2 the square root of 3, the integral 1 over the square root of 3 minus sine x plus 1 over the square root of 3 plus sine x dx. Actually, if we take this here, we get the square root plus square root minus plus minus go, and we get 2 the square root of 3, so this is exactly this one. So we have to calculate E1, this integral dx over the square root of 3 minus sine x, and E2, the integral of dx over the square root of 3 plus sine x. Here, if we use this formula, so we have to calculate 1 over 2 the square root of 3 the integral dx over the square root of 3 minus sine x, and we have to calculate 1 over 2 the square root of 3 integral dx over sine x. This to calculate. For the first one, for E1 and E2. For E1 and E2, E1 is equal to 1 over 2 the square root of 3. The integral will replace dx by, so we have 1 over the square root of 3 minus sine, we have sine x, so this gives us 2t over 1 plus t squared times dx, so 2 over 1 plus t squared dt, which gives us the integral of so here we have 1 over the square root of 3, we have dt over here we have the square root of 3 t squared minus 2t plus the square root of 3. This is about E1. Okay, and this is equal to 1 over the square root of 3 times 1 the square root of 3 integral dt over t squared minus 2 over the square root of 3t plus 1, which is equal 1 over 3 integral dt over, here we can get t minus 1 over the square root of 3 squared, so we have t squared minus 2 over the square root of 3t plus 1 over 3, so minus 1 over 3 plus 1, and this is equal 1 over 3 the integral dt over t minus 1 over the square root of 3 square minus 1 over 3 plus plus 2 over 3, which is equal to 1 over 3 the integral dt over the square root of 3t minus 1 over if we take this here, so here we have times 3 over 2, here we have the square root of 3, if we take so times the square root of 3 over the square root of 2 square plus 1, which gives us here the square root of 2. And here we have this. So this is equal to 1 over 2 the integral dt over we can make a change of variable, so we take the square root, here we take the change of variable, the square root of 3t minus 1 over the square root of 2, this is equal to z, for example, then the square root of 3 dt is equal to the square root of 2 dz, and then dt is equal to the square root of 2 over the square root of 3 dz, so here we have the square root of 2 over the square root of 3 dz over z square plus 1, which gives us which gives us 1 over the square root of 6, yeah, arc tangent z plus 1. Arc tangent z plus 1, this means 1 over the square root of 6, arc tangent, so z, the square root of 3t minus 1 over the square root of 2 plus a constant. And finally E1, which is 1 over 2 the square root of 3 integral dx over the square root of 3 minus sine x, will take this form. So it takes this form, final form. It is equal to 1 over the square root of 6 arc tangent the square root of 3t minus 1 over the square root of 2 plus constant, and it is equal to 1 over the square root of 6 arc tangent the square root of 3t. T is actually equal to tangent x over 2 minus 1 over the square root of 2 plus a constant. This is about E1. About E2, it seems to be actually the same thing. Just I will just start it and stop just before giving the idea. For E2, 1 over 2 the square root of 3 the integral of dx over the square root of 3 plus sine x. We use the same idea, 1 over 2 the square root of 3 the integral 1 over the square root of 3 plus 2t over 1 plus t square, and dx is equal to 2 over 1 plus t square dt. This gives us 1 over the square root of 3 integral dt over the square root of 3t square plus the square root of 3 minus plus 2t. And here we get 1 over 3 the integral dt over t plus 1 over the square root of 3 square plus 1 and minus plus 1 minus 1 over 3. Yeah. So it takes here exactly 2 over 3. So it is 2 over 3. And we will repeat the same thing, exactly the same thing, until obtain this formula. So for E2 it will be 1 over, so for E2 the change of variable will be t plus 1 over the square root of 3. So E2 will be 1 over the square root of 6 arc tangent the square root of 3 tangent x over 2 plus 1 over the square root of 2 plus constant plus another constant, and finally the integral dx over 2 sine square x plus 3 cosine square x is equal to e1 plus e2. So this is equal to 1 over the square root of 6 times arc tangent the square root of 3 tangent x over 2 minus 1 over the square root of 2 plus arc tangent the square root of 3 tangent x over 2 plus 1 over the square root of 2 plus a constant. This is the final result. It was not very easy. Others examples are actually easy. So thank you for watching. Hope to see you next time.